Hello, welcome back to my channel. This is JBTeguihanon, Engineering and Chemistry tutorial. Okay, so let's continue and jump into our topic, matter and energy. So we're just reviewing these topics under the course refrigeration system. So we need to understand matter, right? So what is matter? Matter is commonly explained commonly explained as a substance that occupies space and has mass. Okay, that is the common uh, definition or explanation of this thing called matter, right? Matter. So it has, or is it occupies space and has mass. Okay, and then the weight of the substance. The weight of a substance is the combined effects of the substance mass and the force of gravity pulling down on it. Okay, matter is made up of atoms. Okay, atoms are described as the smallest amount of substance and may combine to form molecules. No? Atoms are atoms of one substance may combine chemically with those with another form to a new substance. These new substances are referred to as compounds. Okay, so if we go to chemistry and then look how chemists define matter, we have this. Okay, so this is chemistry. So this is a general chemistry, and the subject is matter and measurement. Okay, so everything you touch, you feel. So I cannot annotate here. No, I'm just reading on the uh, this word here, matter. Cannot annotate. I cannot mark it. I cannot make circle. I cannot make lines under it. So I just reading it because this is different program. So what is matter? Matter is anything that has mass and make up volume. So this is how chemistry is defining matter. No? Anything that has mass and make up a volume. Volume is space, right? So if matter occupies space, that is volume, and has a mass, then that is matter. So it's the same with the definition here, right? Matter is commonly explained as a substance that occupies space and has mass. So matter has a form, right? So what are the forms of the matters? Solid, then you have liquid, then you have gases. Okay, so the heat content as well as the pressure exerted on the matter determine its states. Okay, so for instance, water is made up of molecules containing atoms of hydrogen and oxygen. Two atoms of hydrogen and one atom of oxygen as a molecules of water. The chemical expression of water molecules is H2O. Okay, H2O. So yeah, so in chemistry, uh, yeah, they also mention the three state of matters or states of matter. Solid has a definite volume and maintains its shape regardless of container in which it is placed. The particles of solid lie, lie closely together and are arranged in a regular three-dimensional array. So in chemistry, they have these three states of water, solid, liquid, and gas. And they have the arrangement of the solid water. Here you can see the on my left side or left side of this presentation, you have the solid, and this is the picture of the arrangement of the atoms. Okay, so common physical properties include melting point or MP, boiling point BP, solubility, color and odor, and then particles a P alters substance without changing its composition. The most common physical change are in the state. So sorry, the physical change alters as a substance without changing its composition. So we have here the close, shall we say, microscopic view of the particles. No? So if you're solid, you're compact, the particle are arranged, okay, and then melting, physical will the physical change, melting will take place, and this is now liquid water. You can see the molecules or particles of the liquid are not arranged like in the solid. So and then you add heat, then you have a boiling, a physical change take place. The water now is become water vapor, and you can see the arrangement of the atoms. Okay, they are now uh, the space are bigger. So here we have the closer look of the ice, which is in the solid form of water. The particles of a solid are close together and highly organized. Right? Left side of the presentation. So photos shown Cap Mauna Kea on the Big Island of Hawaii. And here you have the water, liquid water. The first one is of course solid water, ice. In the liquid water, like this in the presentation, the particles of a liquid are close together but more disorganized. If you look at it closer, right? But more disorganized than the solid. So this is Akaka Falls on the Big Island of Hawaii. And the third presentation or photo and the presentation that's on my right side, the particle, or what we call this gaseous water, the particle of the gas are far apart and disorganized. This is the photo. Steam formed by lava flow on the big island of Hawaii. So all of these are from Hawaii, right? So these are the examples of the solid, liquid, and gaseous state of matter. So the matter that we are referring to is no other than H2O, right? H2O. Okay, so in here, in the uh, presentation here, we have the ice block exerted on its pressure downward, right? Solid exerts all the pressure downward. The molecules of solid liquid have a great attraction for each other and hold together. So this is the macroscopic examples of the solid state of a matter. This is ice, right? Okay, in solid form of water. Solid form of water. Okay, this is solid form of water, or H2O. And then we have here the in figure 2.2, water in the container exerts pressure downward. So you can see in microscopic, this is now macroscopic. The one that we see from the chemistry is microscopic. So in macro, meaning bigger, what you can feel in the bigger view or bigger picture is the pressure of water, right? And the container exert pressure downwards and outwards here, right, to the wall of the container. The downward is the bottom wall of the container. Okay, the outward pressures is what makes water seek its own level. The water molecules still have a small amount of adhesion to each other. The pressure is proportional to the depth. Okay, so as we can see, we have this, we have derived this before. If this is your depth H, the pressure at the bottom here, your pressure here is actually equal to your P there is equal to specific gravity of water times the head. Okay, so that's the pressure if you have that water, right? The deeper the water means if this increases, your pressure increases, right? Because H is increasing, so P is increasing if you hold this constant. Why this is constant? Because same water, same H2O. Okay, so that's it. What else? And then yeah, that's for now. Thank you very much. Please subscribe for those of you who have not yet subscribed. Thanks for watching. Bye for now. God bless.